This is Srinivasan, Assistant Professor, Department of ECE. In this presentation, we are going to discuss on HDL models of combinational circuit. So to start with, HDL stands for Hardware Description Language. We are aware with Moore's law. For every 18 months, the number of transistors within a chip will be doubled and size of the chip gets reduced by 1/3. As digital and electronic circuit designs grew in size and complexity, capturing a large design at the gate level of abstraction with schematic based design became too complex, prone to error, extremely time consuming. And HDLs are specialized computer languages used to program electronic and digital logic circuits. High level languages with which we can specify our hardware to analyze its design before actual fabrication. Two most popular HDLs are Verilog HDL and VHDL. So when it comes to the difference between Verilog HDL and VHDL, Verilog HDL is simple in constructs and VHDL is complex to construct programming. So when it comes to Verilog HDL, we have two different design. One we call it as behavioral, which is structural. So the behavioral is the highest level of abstraction, specifying the functionality in terms of behavior. Example, Boolean equations, truth tables, algorithms, code, etc. And when it comes to structural design, it is a netlist of specification of components and their interconnections. Example, logic gates, transistors, even functional modules. And we have two different design. One is structural and the other one is behavioral. With respect to structural, we go with gate and switches. And when it comes to behavioral, it is algorithmic, where we include loops and process. And when it comes to functional, a collection of registers linked by the combinational logic is obtained by using RTL and Boolean expressions. And next, we'll go with the different levels of abstractions in Verilog HDL. So there are three levels of abstraction in Verilog HDL. 1. Gate level modeling, 2. Data flow modeling, and 3. Behavioral modeling. So when it comes to data flow modeling, it mainly uses to describe the combinational circuit. The basic mechanism used in data flow modeling is continuous assessment. When it comes to behavioral modeling, it is used to describe the complex circuit, primarily the sequential circuit. So let us go with the modeling, behavioral and structural. So if you represent in terms of truth table, in terms of Boolean expression, then it corresponds to behavioral modeling. And if it includes the number of logic gates used in the circuit and their interconnection, then it becomes a structural modeling. So let us go with a simple example, full adder. So the truth table, and on the other side we have the expressions for carry out and the sum. Both belongs to the behavioral modeling. And when it comes to structural modeling, we have a circuit diagram where it represents the number of gates required to construct the full adder and their interconnections between. And now we are going to discuss on how to write programs, HDL programs for gate level modeling, data flow modeling and behavioral modeling. So we are going to consider the same circuit, a full adder circuit. When it comes to gate level modeling, so we use the primitive gates like AND, OR, XOR, NAND, NOR and NO, so as to describe the circuit to carry out the gate level modeling of full adder. So we have full adder with the two off adders. So first, to start with gate level modeling, so we have three inputs A, B, C in, so it can be replaced with X, Y and C in, and two outputs sum and C out. So among these 5 variables, we need to declare which are the input variables and the output variables. The input variables are X, Y, C in, and output is sum and C out. Wire is one which is used to represent the intermediate outputs within the logic gates. So S1 is C1, C2, C3. To start with XOR gate, the first one, S1 is the sum of the first XOR gate where the input is A and B or X comma Y, and the second one is AND gate, so it will give C1 comma X comma Y. The second AND gate C2 y comma C in, and the third C3 x comma C in, and we obtain the OR gate C out C1 comma C2 comma C3 end module. So any HDL program, it will start with module and it will end with end module. And when it comes to data flow modeling, so it uses a keyword called assign, where you can assign the sum and carry with the expression x plus y plus c in or a plus b plus c in. So it will produce the sum and carry with a single statement. And the last one is your behavioral modeling, so by which we use the keyword called always. So whenever there is a change in the value of a, b or c in or x, y, c in, so it will start the calculation of the sum and carry so as to obtain the output. So this is with respect to the gate level modeling, data flow modeling, and your behavioral modeling. So when it comes to the development process of any design, it includes two processes. One is Verilog module, writing an HDL program, and test bench. And test bench is also a HDL program which is used to validate the design. So at the end, we will evaluate the result and will obtain the logical design of the system. And the second part is synthesis part, where we realize the hardware by using a specific software like Xilinx and some commercial CAD tools. So any design of an electronic circuit or a system will include two processes. One is simulation and the other one is synthesis. In both simulation and synthesis, we use Verilog HDL. Thank you.